Hi, Honors Algebra 2. This is matrix multiplication application problems, day 17. So the big thing today is we're going to use matrix multiplication to solve each problem. We may use a calculator to do the actual multiplication. But first, you have to write down the matrices to be multiplied as if you were doing it without a calculator. In other words, show me the matrices you're multiplying in your calculator. Remember that you use the rows of the matrix on the left and the columns of the matrix on the right. Matrix multiplication is not commutative. Hello. So with it not being commutative, that means order does matter. You would see that from day 16 homework. So we have to be careful of the order of our matrix. Let's jump in. Know that there are multiple ways for these problems, and then we can talk more in class. So the first one, the table shows the shares of MBI and CAM stock owned by each person. If MBI stock lost $2.25 per share and CAM gained $1.50 per share, find each person's total gain or loss from the investments in these two companies. Many ways to set this up. Again, order of your matrices matter. So for example, if I want to keep the matrix kind of similar to this, well, I mean, they're all going to be similar, but let's say I want to start with this matrix. In the end, I want find each person's total gain or loss. So in the end, I want to know Peter, Kathy, Bob, and how much they each gain or lose. Let's see if we can make that work. So to start, again, matrices matter. So if I start with maybe, how about BMI and CAM on the top, it's going to be a 1/2. This is how much that company gains or lose. So MBI stock lost $2.25, so minus 2.25. CAM gained 1.5, $1.50. Now, I could have done this many ways, but I'm starting with a 1/2. That means what I multiply by needs to be a 2 by something. These need to match. Since they need to match, their units have to match as well. Since this is MBI and CAM, that means right here needs to be MBI, CAM. They need to match. So that helps me kind of create my second matrix based on my first. So MBI and CAM need to be there. Now we have to think, what am I trying to find? Well, I'm trying to find what each person's total gain or loss. So that means people need to be the top of my columns. This is going to be P for Peter, K for Kathy, B for Bob. And notice I now have a 2/3. So let me fill in the column. Peter, MBI is 72. BMI Kathy is 58. BMI Bob is 30. Why do I say BMI? Body mass index? Yeah. Don't care about body mass index, peeps. We're talking about MBI. And we're just filling in that column. Now our result is going to be a 1/3. Take the first and the last of your matrices. Which means our end, if I multiply these two matrices together, will give me the price, loss or gain, from Peter, Kathy, and Bob. These will be my end units. It's kind of, I guess, price and those people. Please type these two matrices in your calculator. Reference day 16 if you need help with typing in your calculator. And in the end, let's confirm that this is the matrix we get. So please try this on your own and confirm. Okay, hopefully you got this matrix. I'm going to do some labeling so it makes a little sense to us. This is Peter's loss, Kathy's loss, and Bob's gain. Notice the highlighting. These are the end units we have. So I'm going to box it up. This is my end matrix. So Peter lost, Kathy lost, Bob actually gained money. That's one possibility. I'm going to also show another way and whatever one speaks to you. So another way to do this, put a little squiggle, and it will not matter, you will get the same answer, but it's to kind of change up the order of your matrices, which means then flipping some rows and columns. So let's say this time, again using the same data, I'm going to start with Peter, Kathy, Bob as my first matrix and compare them right away to the MBI and CAM. Just an option. Keep in mind it will not look exactly like this matrix right here because it's now a 3 by 2. Again, just match up column and row. This would be 72, 58, 39, 14, 47, 81. Now because that's a 3 by 2, I need to multiply by a 2 by something. These need to match, which means these labels need to match. MBI and CAM have to match the rows of the next column. Well, that kind of helps me set this up then. I know this is like so. And what am I trying to find? I'm trying to find each person's, so right here, here's each person's gain or loss. So this needs to be money. How much did the company gain or lose? Well, MBI lost 2.25. CAM gained 150. So this is a 2 by 1. The result will now be a 3 by 1. I'm going to have Peter, Kathy, Bob compared to money. Please type these two matrices in your calculator. I apologize, there should be a multiplication here, guys. And multiply them. Verify that you get negative 141, negative 60, 33.75. This is for Peter, Kathy, and Bob. Notice it is the same answer as the first way, but flipped, okay, because of the order of my matrices. You do not need to show both ways by any means, but you can verify that it's the same answer this way. Okay, let's try another one. 4 conservationists want to purchase 3 types of evergreen trees, which are available from 3 different nurseries. Assuming each person purchases their entire order from a single nursery, which nursery should each person buy from for the lowest total price? What is the total price for each person? Okay, lots of things, a lot's a way to start, but realize we want in the end, where is it? Which nursery should each person buy from with the lowest total price, and what is the total price for each person? So, let's get started. How about we start with, and again, the first one kind of dictates what you choose from there. Why don't I start with people's names on the row? George, Wally, Chuck, and Bill. Because I know I want them in my end answer, so this would be like my yellow highlighting. And I'm going to compare it to what we have in common, because you know whatever's on top, those labels need to match the right column. So in common, what do they have? Well, the type of tree: spruce, red pine, white pine. So this is going to go on the top: spruce, red pine, white pine. This is a 4x3, which means whatever this needs to start with a 3. Looking above, remember these need to match here. So already I'm setting up my next matrix because these need to match, so their labels need to match. In the end, I want person compared to what nursery. So nursery needs to go up here. Look at my highlighting. This will be extremely helpful. So on top, I now want nursery A, B, and C, which in the end will leave me with a 4x3. This is the hardest part. Filling in the matrix and doing the multiplication, that's okay. But this part is tough. So watch my highlighting. Realize when you multiply that the rows and columns have to match up with the middle. And now we can start plugging in our information. This is one way. So if I fill this in, George with spruce is 25. Wally with spruce is 40. Chuck with spruce is 14. 30. Let's keep going. I'm taking this right from the table above. This is my first matrix. I can type it into my calculator. My second matrix is comparing spruce, red pine, white pine with the nursery costs. This is 1.45 at nursery A, 1.5A at nursery B, 1.60. There we go. I wrote like a giant. I'm sorry, I'm gonna go a little bit smaller over here. When you type these two matrices in your calculator, make sure the order matters. You need your names on the left and nursery ABC on the top. Those yellow highlights are our ending units, right? They're the 4 column on my left and the 4 rows on my left, 3 columns on top. Do this multiplication and let's verify that you get the same answer as me. if you did not get the same answer, please double check that you put the matrices incorrect, as well as you have the correct order. If you have it reversed, it's not going to work. Now, the one thing about this problem is this is telling us how much each person pays at each nursery. It actually doesn't answer the question for us. We want to know what is the total price and what nursery should they choose. So we cannot just circle this matrix and say, voila, that's the answer. We need to go a little bit further just based on the problem. So we want to know, what nursery should George choose? Well, looking at George's column, George's row, I would definitely pick nursery C. Right, it's the cheapest for $148. Now let's go to Wally. Looking at Wally, the cheapest nursery would also be C, because that's only $189. Just looking at their row. Chuck, cheapest, again, would be C for $109. And our last, good old Bill, also nursery C for $127. So just be a little careful if it asks for a question like this, that you show the final answer. Now I'm not going to go in detail, but I am going to show one other way to set this up. Whatever speaks to you is fine by me. This time I'm going to start with nursery A, B, C on the left side. So this would be my yellow in my final answer. My red that needs to match the red here, the nice multiplication, has to be what they have in common. Well, I can compare nursery ABC with spruce, red pine, white pine. That means these need to match. And in the end, I want ABC, nursery ABC, compared to each person. And we can fill out a matrix like this. George, Wally, Chuck, and Bill. This is another way you can make your matrix. You will get the same answer. This is a 3 by 3 multiplied by a 3 by 4. These match. And in the end, you'll have a 3 by 4, and you can answer the same problem. Depends on how you want to set it up. No preference by me. See if we're getting the hang of it. Let's do another one. Number 3, the table shows the hour each babysitter worked for the Jones family and the Smith family for 1 month. If Jane charges $1.50 per hour, Juan charges $2 per hour, and Jill charges $2.5 per hour. What is the total each family spends per month for the babysitter? Okay. In the end, we want total each family spends per month per babysitter. Let's think about what we have in common. What could be the top, your column label, that can correspond with the row label? What do we have in common? Well, Jane, Juan, and Jill, right? They're common in both situations. So I'm going to go J-A for Jane, J-U for Juan, and J-I for Jill. These match here. They need to be the same. So it's a something by 3 times a 3 by something. And I want to know how much each family charges per month for a babysitter. So that's going to mean, because I chose it this way, this unit right here is going to be the money compared to the family names here. This is going to be Jones. I'm just going to write it out. And this will be Smith. Okay, it's dictated by the red. So, Jane charges 1.5. Juan charges 2. Jill is $2.50. How many hours are they babysitting? This is 15, 18, 12. I'm just looking at the chart above. 10, 6, 5. In the end, when I do this matrix multiplication, I will have money compared to my families. Please type this in and let's see if we get the same result. This is your matrix. Multiply them together. And that should be the total that each family spends. The Joneses spend $88.50. The Smith family will spend $64.5. How much will each sitter earn per month if the Jones family paid each sitter $3 per hour and the Smith family paid each sitter $3.50 per hour? Okay, a little bit different. In the end, we now want how much each sitter will own. So I'm going to set it up where, okay, this will be money. In the end, I need it to be sitters. So this is going to be Jane, Juan, and Jill. What matches in the middle has to be the families. That's the only thing left, and it needs to be in common. So the families will go here and here, which this is the Jones, Smith, and it needs to match here. Jones, Smith. Again, this is one option. So if you like a different way, that's fine with me. I'm not going to be offended. Let's make sure we fill in the table properly. Jones pay each person $3. Smith pays each one $3.50. I'm going to move this over so it kind of fits better with my label. Sorry about that. Fill in this chart. Jones with Jane. 18, 12, 10, 6, 15. So in the end, when you multiply those, you're going to end with money per babysitter. And that's exactly what the problem wants. Look at the colors. Good thing that the reds match. And now when you multiply, let's verify. So please pause the video. Make sure you get this. It'd be 80, 75. Jill's making the money load. She's going to make 88.5. So many ways to set them up. I like looking at colors, looking at your end units, and looking what you can have in common. Okay, number 4, nachos, super nachos, nacho grande. Let's get this going. So there's 3 sizes for the nacho meals, which contain different amount of chips, cheese, and salsa, and also shows fat, calories, salt for each item, production cost per serving. A lot is in this table. Part 1, Part A. Find the fat, calories, and salt for each of the 3 meals. Okay, so maybe I'm going to start with looking at my result. And this is going to be my result matrix here. What units do I want in the end, in my final one? Well, I want the fat, calories, and salt for each of the 3 meals. So I can do nacho, super nacho, nacho grande, because those are my 3 meals. And I want to know the fat, the calories, and the salt. That would be in the end, fat, calories, salt. Now I need to see what units should go on the top and the side, because those need to match and they need to be the same. Well, when I'm comparing these, I'm actually comparing the chips, the cheese, and the salsa. How much are they individually? And multiply. So this is going to become, I'm going to go CP for chips, CH for cheese, and S for salsa. They are the same. It's a 3 by 3 times a 3 by 3, so my result will be a 3 by 3. This is the hardest part. If you can get to this with a little bit of thinking, you will be fine. Think about what you want in the end and what you have in common. Now it's the fun part. Let's actually fill in these matrices. So I'm going to make this a little bit smaller. Let's see. We're comparing. Whoa. Chips in the nachos is 2. Cheese in the nachos is 1. Salsa in the nachos is 1. Chips in the super nachos is 3. Cheese in the super nacho is 2. Get the idea, you just read the column above, watching out for your labels. Now we're looking at chips, cheese, and salsa compared to the fat, calories, and salt. I'm going to go down a little bit. This one will be 40. And now you can multiply them together. Please show me these steps so that I'm able to follow and see if you accidentally put a wrong number somewhere and help you out. Right now, type these 2 in your calculator. Let's make sure we get the same results for how much fat, calories, and salt is in each meal. Hopefully you got this right. It's a lot of typing in, so if you do not get this, please go back and check your matrices that you typed them in properly. But this shows how much fat, calories, and salt in each of the 3 meals. Next one, find the production costs for each of the 3 meals. So that means in my end, let's start here. So my beginning column, trying to figure out what these will be. It's a great way to start with these problems. So I want production costs for each of the 3 meals. So this can be my 3 meals: nacho, super nacho, nacho grande. And in the end, this will be the cost. You can just put money, or I usually leave it blank, that's fine. So then it's nacho, super nacho, nacho grande, and price. Okay, we're getting there. Now I need to make my matrix. What units do we have in common? What can go on the top and the side that are in common, and will talk to me about price? Well, if you look at it, price right here is only compared to chips, cheese, and salsa. that helps me figure out that my red needs to be chips, cheese, and salsa, because that's the only way I can put in money, that production cost. So again, this little tips on figuring this out. This is my chips, my cheese, salsa, needs to match here. And now I can solve my matrix. Let's see. Chips, cheese, and salsa. Oh, look at that, peeps. We actually already have that matrix above. Use it. Save those matrices, because now it's one less you have to type in. Beautiful. Next one. Chips, cheese, and salsa compared to money is 15 cents, 22 cents, and 18 cents. Now we can multiply these. A 3 by 3 times a 3 by 1 will give me a 3 by 1 in the end. Let's check your math. This would be 70 cents. This should be 125 and 177. So that is how much each will cost. Nachos cost 70 cents for production. Super Nachos cost $1.25. And Nacho Grande will cost $1.77 in production costs. Okay, so hopefully you're getting the hang of it. You're trying these out. The last part C is Nate Nachos has 26 servings of chips on hand, 15 servings of cheese, and 12 servings of salsa. They made up Nachos' plate to use all of these supplies with nothing left over. How many of each plate did they make? Now, this one's special, my loves. So I'm going to write it in orange, always special part at the end. We have to watch out for this because this is actually going to use an inverse idea. If you need help calculator assistance with this, you can ask in class, of course, or reference day 16 video where we talk about how to put inverses in a calculator. So let's get it set up and then we'll talk about any calculator things we need. So in the end, we are trying to find how many of each plate they made. So one of my matrices, and I know this is going to be weird, one matrix that I'm finding is how many nachos, how many super nachos, and how many nacho grandes are there. And look at how I'm setting it up. It's part of my variables. Looking at it, since this is a column, that means it needs to match up here. So working my way backwards. Nacho, super nacho, nacho grande. And I'm trying to find how many plates of each do they make? Well, when I compare nacho, super nacho, nacho grande, I'm actually going to compare it to the chips, the cheese, and the salsa. Right? That's pretty much what we've always compared nacho, super nacho, nacho grande to, because if you look at the chart above, that's where it continues. It matches up with chips, cheese, and salsa. So that's the only matrix I can make from it. And it's actually the right one because my final answer is all about, I'm going to show you my colors again. It's going to all be about how many chips you have, how much cheese you have, and how much salsa you have. The problem tells me I have 26 servings of chips, 15 servings of cheese, and 12 of salsa. So that's another way to double check. This is the correct matrix. The inners match, the outers will be the result. But now, instead of actually putting in numbers for this second matrix, we're trying to find it. We're going to do inverse. First off, let's fill out our table here. Nacho, super nacho, nacho grande compared to chips, cheese, salsa. I want to find this matrix N, Sn, Ng. Let's review. If I am doing inverse, the only way to get this matrix to the other side, you cannot divide matrices. Instead, you can multiply by the inverse. So think of this as A times matrix B equals C. And you want to get B by itself. That means B can equal A inverse times C. This is the only way to get B by itself. Multiply the other side by the inverse. So let me show you what that's going to look like. I'm going to do a little arrow, maybe that will help. So my matrix B is my Nacho, Super Nacho, Nacho Grande. That's going to equal the inverse of the matrix A. So how I'm going to write that is matrix A, 2, 1, 1, 3, 2, 2, 5, 3, 2, with the -1 power. That shows me inverse times the C matrix, 26, 15, and 12. When you do inverse on your calculator, remember to type that matrix in, call it A, but at the very last step, make sure you use the x raised to the -1st power. Please reference day 16 notes or ask about this in class, because in the end, your final matrix, when you multiply the inverse of A times C, should give you 4, 1, 3, which means you'll have 4 nacho plates, 1 super nacho, and 3 nacho grande. Last one. Please try this one on your own first. Okay, hopefully you gave it a try. I'm going to go through it now in detail so you feel good, solid, sweet about matrix application. Part A, find the number of each type of candy needed to fill the order. Probably should have read the problem. Here we go. The company receives an order for 300 traditional, 180 deluxe, and 100 superb assortments. Find the number of each type of candy to fill the order. Well, we are given caramel, chocolates, hard candy, and we need to find out how many boxes of each. Okay, so let's start with the middle. What do we have in common? What could be the top and the side? Well, in common would be the traditional, deluxe, superb. So, traditional, deluxe, superb. In the end, I'm finding the number of each type to fill the order. So I'm guessing, this should be the amount, and this will be caramels, chocolate, hard candy. Because in the end, I want chocolate, caramels, chocolate, hard candy compared to cost. Now the fun part, fill in the matrix. You need 300 traditional, you need 180 deluxe, you need 100 superb. Let's compare how much is in each box. Caramels traditional, deluxe, caramel. Just make sure your labels match up. This is a 1 by 3 times a 3 by 3, so the answer is a 1 by 3. Type it in. Our units match in the end, so let's see if we get the same answer. that is how much caramels, chocolate, and hard candy you need to fill that order. B, find the total number of calories in each assortment. Okay, so now we want calories in each assortment. So calories in each assortment. Well, calories is 60, 70, 55 per assortment, which is traditional, deluxe, superb. So in the end, here and here, I want this to be calories, which can look like that, per traditional, deluxe, superb. These are my calories per traditional, deluxe, superb. Which means in the middle, these column and row need to match. And what can I compare? Well, I can compare caramels, chocolates, hard candy. One by 3 times a 3 by 3 will give me a 1 by 3. Let's see how many calories are in each. We have 60, 70, 55. This chart is very similar to above, but flipped, so we have to redo it. 10, 12, 10, 16, 8, 16, 15, 25, 8. Put these in your calculator. Make sure you type them in properly, and we're going to get our results. And that should be how many calories are in each assortment. Find the production cost for each type. So in the end, I want cost per type. So setting up, this will be price. You'll see the pattern, hopefully. You guys are catching on. This is going to be cost. If I could write. And this is going to be for your 3 types, because that's what I want in my final units. Now I need to figure out what units match in the middle. Again, the one thing that both those have in common, if I look at the table to try to find values, is my caramels, chocolate, hard candy. 1 by 3 by a 3 by 3. In the end, you should be getting $2.74, $3.04, and $4.75. Sorry, that got messy. So I'm going to leave that matrix for you guys to fill out. I got it all set up. You just need to fill in, multiply, and confirm. Find the cost to fill the order. Last one, find the cost to fill the order. We're going to be using the problem from above times how many orders we have. So this one's actually pretty fun. You're going to be using the matrix from here. So I'm just going to boop. Right, we need that. We need to know how much it costs per traditional, deluxe, superb, to then multiply it by how many was in the order. So this is going to be fun. Traditional, deluxe. Actually, I'm on a nice iPad. Let's be smart, peeps. Voila. Oh, close. Forgot the T. So we're doing traditional, deluxe, superb, which means, I'm going to change my color so I don't mess you guys up. This needs to match here. And this is how much is in the order. Well, there's 300 for the traditional, ordered. 180 were ordered of the deluxe, and 100 for here. Multiply these two major C's together. You're going to end up with cost in total, right? Because it's going to be a 1 by 3 times a 3 by 1. So my result's a 1 by 1. Do this multiplication. You should get 184.20. That's how much it costs. Please feel free to rewatch problems of this video. Ask questions in class. Talk with people. It will help if you talk. I'll see you guys soon. Email me. I'll see you soon.